So here, this is going to be finding the greatest common factor of just two numbers, so no word problem or anything here. So what's the first step in finding the greatest common factor? Yeah?
Is it even or is it odd?
Yeah, that's kind of first step of doing your trees, right? I mean, that just helps you to break it down. I mean, yeah, it is, but that just helps to break it. Yeah, we want to do our factor trees first, right? Our prime factorization. So I broke this to 7 and 8. I know that 7 is prime. Now we're going to break it to 2 and 4. And then I remember I'm circling once they become prime. And then for 32, I'm going to do 4 and 8. And then 2 and 2. Make sure we're circling them. Okay, 2 and 4. And then 2 and 2. Okay. Now, do I have the prime factorizations for 32 and 56 written on the board? No, I do not. Now, what I'm going to do before I go any further is I'm going to pull up the answer. So let's see how we did. So as a class, we said, most of us in here said that the answer was 8. Now, we had one person select 2, and we had a 16. So let's try to find we had actually 2 people select 16. So let's try to find what maybe those 3 people made a mistake on there. Okay? So, of course, we need to stack these up. So 2 times 2 times 2 times 7. Now, remember, a good skill to do at this point right here on a test is just make sure that this equals 56. Like, actually do it in your calculator, 2 times 2 times 2 times 7. Because a lot of times with 56, a lot of people think it's 9 and 6 makes 56 or something like that, and then it messes up the whole problem. Okay, so just take the extra couple seconds to multiply your factorizations out to make sure they equal what they're supposed to. So then we have 2 times 2 times 2 times 2 times 2, right? 5 2's there. And again, if you multiply those out, make sure you're getting 32. Bless you. Okay? Now we're going to look for what, guys? At this step, what are we looking for? Yep. Before we find the greatest, we've got to find the CFs, just the common factors. So we're going to go and see, okay, well, I see that I have common 2's. I have common 2's, and I have another common 2. And then I'm going to use how many from each common?
1.
1 from each. Good. And then I'm going to multiply them. Now, the good news is nobody put 6. That's awesome. That's a start. We're starting to realize that it's not 2 plus 2 plus 2. It's multiplying all the 2's, which is where we would get 8. So what I'm thinking, whoever missed this, the person that got 16, or the 2 people that got 16, I'm thinking maybe you thought that was a 2. Maybe your handwriting got a little sloppy, or maybe you just didn't do the right your prime factorization. Maybe you did 4. I think that was it, actually, wasn't it? If you would have done this is wrong, but let's say you had 8 and you broke it down to 4 and 4, right? Then you did 2 and 2, 2 and 2. That's what it is. So then you would have had 4. You would have had this for 56, and this is wrong, but this is what you would have had, like that, which would have made you have 4 2's in common. 2 times 2 times 2 times 2 is 16. So just remember, it's not addition, it's multiplication. We're still making that mistake. Now, for the person that got 2, I'm just thinking you forgot to look for other common factors. Okay, you found the one common factor, but you didn't find the other ones. Does that make sense? Okay. All right, so now we're doing a comparison question where you have to tell me if a number is greater than or less than. Remember, or equal to. You have to show work. Now, I'm going to show you exactly what work I'm requiring here. First of all, let's look at what all you guys put in. Number 1, like we just did. Whoops, that's not right. That's the leaderboard. We'll look at that too. Remind me, and I'll show you the leaderboard. Here we have 16 of you said it was A, it was greater than. We have 4 of you saying it was less than, and we have a few of you saying equal. Okay, so the correct answer was A. So let's go through and figure this out how we would do this. Now, remember, when we do this, guys, we have to remember that all fractions are division problem. So we have to remember, first and foremost, that 7 and 2/3, isn't that going to be 7 point something?
Yeah.
So, and remember, turning them to decimals is going to be, I think decimals are easier to compare than fractions. I think we would all agree on that. Okay, fractions, you can do it, but then you got to do a common denominator, you got to do what you did to the bottom to the numerator, all those steps, right? It's a lot more steps. Decimals are a lot easier. So I'm going to go ahead and just bring 7 point over, because I know that 7 and something would be 7 and something. Does that make sense? Now I know that all fractions are division problems, so I'm going to take the fraction 2/3, and you can use a calculator on this, and I'm just simply going to type in my calculator 2 divided by 3. Remember, it's always first top number, numerator, divided by denominator, or the bottom number. Now when you do that, your calculator is going to give you a bunch of 6's, and then a 7 at the end. Now I'll tell you why the 7 is there. it's not that there's really a 7 at the end. It's the fact that your calculator can only go to so many digits. Okay, there's only so many it can show you on your screen. The screen's only so big, right? Really, what that equals, 2 divided by 3, is 0.6 repeating forever and ever and ever. So, forever. That many 6s. Does that make sense? Okay, so why is the 7 there, you might ask? Well, if I wanted to round right there, what would that number become right there?
7.
A 7. Wherever I want to round, it's going to become a 7 because every number to the right is 5 or more. Does that make sense? So basically, however many digits or how many place values your calculator gives, I don't remember how many, but obviously this place value right there is the last one they can show you. Get your head up. That's the last place value that they can show you. So it's going to do rounding rules. So if we know a 6 is after that, it's going to go to 7. Does that make sense? So this does not mean 7.666666667. It doesn't mean that. It means 7.6 repeating. Now, a lot of people got 7.6 and they said, oh, well, that just means that they're equal to each other. Are they equal, guys? Not at all. Not at all. What do you need to add in here? What can you add after?
0.
Yeah, you can add zeros. Good. So we're going to add zeros. Now, I really don't need to add all these, but I will just for you guys right now so you can see it. Okay? So now remember, when you're doing comparing of fractions, or I'm sorry, decimals, you're going to work your way left to right. So we're going to start in this place value since it's the furthest to the left. Do we learn anything about the number from that place value? No. What about here? No. What about here?
Yes.
Yeah, because that 6 is bigger than that 0, none of this other stuff even matters at this point. Does that make sense? Huh? 7 doesn't matter. Because we know right here that this 6 is bigger than that. So we have 6 hundredths here. We have 0 hundredths there. So therefore, we know that this one has to be larger, 7 2/3. Does that make sense? Okay, let's try another one of those. It's below there. We're going to do the one below it now. Go ahead and start that one. 4 ninths and 431 thousandths. Make sure you show your work, though. Okay, so on this one now, we're going to go ahead and hit N to see which one's bigger there. And we see that the majority of you, 19 of you, said it was greater than. We had a few of you still miss it there. It is A. Okay, now let's talk about why it's A. Okay, when you did 4 divided by 9, what do you get? What did you get when you actually did 4 divided by 9? Riley?
0.444444.
Right, and that would be written like this, by the way. I don't know, it seems like some people in elementary learned this and some did. This is called a repeating decimal. Did you guys learn that?
Yeah.
Okay, and you put a little line over it. That just means it goes on and on forever. Now, you could write out all those 4s, but what I want you guys to see is you don't need to. You could just, since you have 3 numbers there, just put 3 of those 4s there. Okay? Now, we are going to work our way left to right. Do we learn anything in this place value?
No.
Do we learn anything in the tenths?
No.
The hundredths?
Yes.
Yes, because that 4 is larger than the 3, none of this other stuff matters. We know that this must be the larger one, therefore my inequality symbol would be trying to eat it. Does that make sense?
Yes.
All right, so prime, composite, or neither.
Wait, Mr. Garrison?
What? So,
Are you never mind.
okay, so it is a composite number. Now, we had 3 of you missing this, so please listen up. Now, who remembers real quick, what's the process that we go through on these prime and composites? And it will help you. We just got to make sure we're using that process. Go ahead, Pinhead.
Is it even or is it not?
Yeah, we ask that question. Is it an even number or is it an odd number? Because that'll kind of give us some clues. And the reason why we ask that question is because if it is an even number, is it?
Yes.
Yeah, this one, and I'll highlight it in green so you guys can see it. We see that it ends in an 8 right there, so we know this is an even number. So what do we know it has a factor of right away? It has a factor of 2. Now remember, composite numbers have 3 factors. So that means this number, we know for a fact it has the number 1 as a factor. Agreed? We also know that it has 15,238 as a factor. Agreed?
Great.
Okay, now all we have to do is find one additional factor to make it composite. And because it's even, we know that all even numbers are composite, except for 2 and 0. Those 2 are not composite. But 4 and larger even numbers are always composite. Okay, make sense? Okay, let's go on to, I want to go on to this one now. I want you to do that same process. Let's go to number 2. Is it prime or composite? Not place. Okay, so here we go. we are going to go ahead and end this. Now you can see the majority of you, once again, on this one, they're getting it correct. 20 of you
Yes.
said it was prime. Good job. We did have a couple say composite. Now, my question to those individuals, and they don't have to answer it because they don't need to tell anybody that they missed it, but they said it was composite. So evidently they said that this number can be divided by something other than 1 and 23. It's okay. So that is what we have to check. So that's why we do the process here. If it's even, we know it's composite if it's larger than 2. Since it's odd, this number is clearly odd, right, everybody? So we are going to check 3, 5, and 7. We're going to ask ourselves, we have to make sure that this number, 23, doesn't have factors of 3, 5, and 7. Another way to say that, I have to check to make sure 23 is not divisible, evenly divisible, by 3, 5, and 7. So you could just go through here and do 23 divided by 3, 23 divided by 5, 23 divided by 7. You could do that. You have a calculator. But I would rather you really focus on the rules. So you'll remember the rule for 3 says, if you what? Cody?
When you add the digits together and it's divisible by 3.
You got it. So you add the digits, you get 5, right, everybody? Does 5 have a factor of 3?
No.
No, it does not. Now, some people get confused and say, well, 5 has a factor of 5. Okay, that's not how this works. Once you use the rule for 3, you get rid of it. It only works for checking 3. The rule for 5 says the number must end in a 5 or 0. Does that end in 5 or 0? No, so it's eliminated. Then we're finally at the number 7. There's not really a rule. You may just have to divide it. Or you can just think about everything that is divisible by 7. So 7 is divisible by 7. 14, 21, 28, 35, 42, 49, and so on. Zach, stop. Okay? So because I didn't say 23, we eliminate that. Because we eliminated those 3 factors, we know that that is a prime number. Everybody got that? Okay. Let's do one more. I would like you guys to do number 5. Prime, composite, or neither. Go ahead. Okay, look. So here we go. So the correct answer here was B. It is a composite number. Now this is a confusing one. Quit writing on your boards and look at me. Okay, this can be a little bit of a confusing one. All right. Remember, we got to ask the question. If you guys go through the process, you will never miss one of these. If you try to do it mentally, you're going to miss it. Remember, 39, is it going to show up on your multiplication table anywhere?
Yeah.
No, it is not. Nowhere. No.
3 and 13.
3 and 13 is not on the multiplication chart anywhere. Your multiplication charts only go up to 12,
Oh, okay.
right? So that's why 39 doesn't look, it looks prime, does it not? It does. It absolutely looks prime. Avery, you with me? It does. But you've got to remember to go through the process on some of these. And you've got to check 3, 5, and 7. Okay? So we check 3 by adding the digits. What's 3 plus 9? Ask yourself, is 12 divisible by 3?
Yes.
Yeah, so that means 39 has a factor of 3. So therefore, we know that 39 has factors of 1, 3, and 39 at least. It also has 13, but we only care if we can find the third factor. Does that make sense?
Yes.
Okay. 57 will be the same way. That's one that people think is prime. But 5 plus 7 is 12, which is divisible by 3. Everybody got that? Just go through the process. If you do that, you'll be good. Okay? All right. I want to go do... Looking for one. Hang on. Go ahead. Find the LCM of 24 and 36. Everybody got it right? Okay, so find the LCM of 24 and 36. We had pretty much everybody get it right. We had a couple people put 24. We'll talk about that in a minute. And then we had a couple people put 144. So they must have had an extra 2 in there because 72 times 2 is 144. So evidently they had an extra 2. It's kind of a little silly mistake there, evidently. But that's good. So we should obviously start with our trees, right? So that's going to be 3 and 8. And then 2 and 4. I know I'm being sloppy, but just trying to save a little bit of time so we can get on to something else since everybody got it right. 2 and 3. 2 and 3. Now remember, when you stack up your prime factorizations, guys, just take a quick second to multiply these out right here. Okay? Just make sure it equals 24. And make sure that this right here equals 36. That's just a quick little calculator thing that'll take you 5 seconds. Stop. All right. Now we're going to look for CF because, again, the first step to finding LCM is finding the GCF, right? So we are going to take this, and we are going to circle. Circle. Are there anything else in common? Or is there anything else in common, I should say? And then we're going to go 2 times 2 times 3. So what's the greatest common factor?
12.
It is 12. Now, awesome. I'm really happy that you guys, nobody put 12. That's good. That shows me that you're separating the two, GCF and LCM. Now, when you are finding the LCM, remember, you're going to take this number, the GCF, you're going to take it, and you are going to multiply it by anything that's not circled. Now, that doesn't mean anything's not circled over here. You're going to multiply it by any of the factors that work in common. Okay? So it's that and that. So times 2 times 3, that would give you 72, which is your LCM. Which makes sense because that number is larger than both those numbers. Now, for the person that put 24, think about this for a minute. If you said the least common multiple is 24, what's the first multiple of 36? 36. So could you have something small? Could you have something in common smaller than 36? No, you couldn't. All right, let's go on to the next one. Gotta find the one I'm looking for here.
Well, I can see where they get 12, because 12 times 2 would equal 24, and 12 times 3 would equal 24.
Oh yeah, I understand.
No, I don't know how they got 24.
All right, guys. Hey, listen up. Make it a little bigger. There we go. Now we can see it. Okay, I'm gonna read it. If it's hard to see, I'm sorry. I tried to make it bigger, but okay, we're only gonna do number 1. So I'll read it to you, and then you guys are gonna decipher what type of question it really is. Okay. So it says, I am organizing my coaching materials into boxes. No emphasis on that or anything. So that only basketball or football stuff goes into one box. The coaching materials will be put in boxes so that each box has an identical amount of coaching materials in each box. We have 36 items for football and we have 48 items for basketball. What is the greatest number of coaching items that would go into each box? So you guys go ahead and get started on that. Do not worry about number 2 and 3 yet. All right. So we talked about this question a little bit. This one. The hard part isn't finding what you have to find. It's figuring out what you're actually trying to find, if that makes sense. So on this one, let's see how we did, first of all. Yeah, the answer was 12, so the majority of you did get it correct. Had a couple people get 4 and 6. I think I know what I think I know what both of them did. We'll talk about it in a minute. It's a very easily correctable mistake. Guys, you have to know anytime we're putting things into groups, we're taking different objects and we're putting them into groups or packages or containers or boxes. Any type of grouping. We know we're always talking about GCF, right, guys? But even more than that, guys, the key word was right here. Look, right here. If you see that word, that's the easiest one to identify. I should see eyes up here, please. Okay, you see the word greatest, you know it's GCF. Okay, then you also saw words like identical. We saw words like boxes. We saw like each box. Those kinds of things. And then, of course, you had your items. So you should have done your trees and everything there. What's up?
So if you don't, even if you don't see the word greatest, is it still possible for it to be a GCF question?
Yeah, it might not say. It might just say what's the most or what's the, how many, what's the, yeah, it could. It's all about putting into groups. Let's put it this way, guys. If I did this, and I'm going to skip the trees, even though you guys should never skip the trees, I'm going to do that. And that's 36 right there. And then this one is going to be 2 times 2 times 2 times 2 times 3. That's 48. Now, if for the people that got, I had some people get 4. I think that for the person that got 4 as their answer, you didn't see those common 3s right there. For the person that got 6, you didn't see those common 2s, and you just had the common 3s. That's 6. You have to make sure we're seeing all of those to find 12. Now, let's say you went and found the LCM accidentally for a minute, okay? And then you did 12 times 2 times 2 times 3. When you do that, that is, I think it's 108, I think. 6, 12, no, it's 144, right? Is that what everybody got, Scott? Yeah, 144. If you got 144 as your answer, that's an LCM. You should go, wait a minute here. If I got 36 football items and I got 48 basketball items, am I going to be able to make 144 boxes of materials? No. So that's what it would mean. Now, how many, we'll just kind of do this one together. If we know that the greatest number of coaching items that would go into each box would be 12, how many boxes am I going to need for football then? No. I'm going to take 36 items and I'm going to divide them up into the 12 that are going to go into each one. That's going to give me 3 boxes, right? And then for basketball items, Alec, what are you doing? For what? 48, we're going to do 48 divided by our GCF, and that's going to give us 4. Does that make sense? Okay. This one here. First of all, let's do this before we start. I want you guys to key in whether it's A, an LCM question, or B, a GCF question. Let's start there. Ready? Go. You don't have to write anything. Just tell me real quick whether you think it's an LCM or a GCF. Okay. And the majority of you said it was A, LCM. Now, we had a few of you say B, a GCF. Now, the reason why this is LCM, well, let's just read through it. I have to practice the alphabet with my son Case, and every 12 days I practice basketball with him every 8 days. If I did both of those today, when is the next time, or in how many days, Riley, in how many days will I have to do both of these on the same day, right? What words are what are your key words there that help you to see what's what? Yeah? Same time. What's another one?
How many?
I'm not sure how many, because how many could go for either GCF or LCM? Again, right there, guys. And what's the last one? There's one more. Jaden? That's important, but that doesn't help us know whether it's 12 or whether it's LCM or GCF. Yeah? No. Yeah. You said it a minute ago. I just heard you. Future, right, guys? Now, remember, you might be saying, well, the word future isn't there, Mr. Garrison. I know that. But it's 2 things are happening on the same day, and then we're trying to figure out when they're going to happen again on the same day, in the future, right? Right, guys? So, let's go ahead and we're not going to find the LCM here. Let's just say this. I'll tell you the GCF, it equals 4. Ask yourself if that would make sense. Like, if I did both of those sums with Casey this morning, would I do either of those things in 4 days?
No.
No, because I'll do the other one in 8 days from now. I'll do one in 12 days from now. The LCM there would be 24. Let's do another one like that. Go ahead. Same thing. We're going to do A for, what do we do? A for LCM? A for LCM, B for GCF. A for LCM, B for GCF. Hey, nice job. Everybody got it right. Good job. That is absolutely an LCM question. Now what I want to do, and because you guys all recognize future, we all recognize same time, next time, these are all keys. We recognize that it was in the future. Now, I want you guys to do this. Okay? Now, if you're wondering how to put times in, remember, if it's 630, we would just type in 630. Something like that, okay? We don't put a colon in. Everybody go ahead and do that now. All right, so we ran out of time there. Now, I'll tell you this. We have a lot of different answers here, which tells me some of you weren't really listening at the beginning of that, which is okay. You will have one like this on the test tomorrow, so I'm going to take the last 30 seconds here. I know it's about time, but just hang with me for a second. The answer was 330. Now, the people that got 120, you were like 90% of the way of having the answer correct. We've got to read carefully. So first of all, I've already got the work done here, and as you can see, I know that the LCM is 120. So what that means is, the LCM is 120. That means every 120 minutes, Skylar and Abby are going to finish a chapter in a book at the same time, right? Everybody got that? That's when they're going to finish, every 2 hours, because 120 minutes is 2 hours, right? The question says, when? It doesn't say in how many minutes. I see people erasing, and I hope you're all listening, because this is going to be on there. I'll say it again. It doesn't say in how many minutes will they both finish the chapter at the same time. That would be 120. you actually have to take this 120 minutes and think, well, I know that that is 2 hours. So that means if they start reading at 1:30, that means that at 3:30, they will both finish at the same time, which means if they keep reading, it'll be then 5:30 when they finish at the same time again, and then 7:30, and then 9:30. Everybody got that? There will be one like that on the test tomorrow. Go ahead and put your clipboards and stuff up.